In this video, we have Claude Giroux of the Philadelphia Flyers. He attempts a slap shot during a game against the Pittsburgh Penguins. If the shot is clocked at 42.2 meters per second and his hockey stick is 1.3 meters long, what is the angular velocity of his hockey stick? So the first thing we do is, of course, we draw a free body diagram. I'm sorry, not a free body diagram, just a picture of what's going on. Then we want to write down our givens. Now we have this number 42.2 meters per second. And it's a velocity, but we need to know which one is it. Is it our angular or is it our tangential velocity? And the way to always tell is the units. The units always give it away. A meter per second is a unit for a tangential velocity. Whenever we have meters, we're going to use an English letter for a symbol. If ever we were to have radians, we would use a Greek letter for a symbol. So this is going to be an English letter, meters per second, just like our old idea of velocity. We're going to use the letter V, just like our old idea of velocity. Next thing we have is 1.3 meters, and that represents how long the stick is. Now, when the hockey player holds the stick, there's the hockey player's glove. And when they hold the stick and swing it, it's going to swing in a circle with their hand at the center. And therefore, the length of the stick itself is the radius of that circle. So we know the radius, we know the tangential velocity. We want to know what is the angular velocity. And that's our Greek letter omega. The equation we're going to use is that the tangential velocity is the radius times the angular velocity. We have the tangential velocity of 42.2. Our radius is 1.3. We're going to solve for the angular velocity. We solve by dividing each side by 1.3. Or to get something connected by multiplication, we divide to get rid of it. This gives us an angular velocity of 32.5. And when we're using this formula here, we must be units of radians. In this case, radians per second.